Now we're going to solve some logarithmic equations, equations that have log terms in them. Our first method is going to rewrite the equation in exponential form, which is like the base with the exponent equal to what we're taking the log of x. And then we can solve for x. All right, so let's take a look at this first example. If we identify what our base is, because it's natural log, that means our base is e. Our exponent is 2. And what that result is x minus 1. So if we rewrite in exponential form, right, we are going to have the base e to the exponent 2 equal to x minus 1. Now we solve for x. Add 1 to both sides, we get x equals e squared plus 1. Now let's look at this one. We want to rewrite it in exponential form. So let's identify the base. Well, because it's a common log, it's base of 10. The exponent is 2. And the result of the log is 3x minus 4. All right, so rewriting this, we are going to have the base of 10, exponent of 2 equal to 3x minus 4. 10 squared is 100. Equals 3x minus 4. Add 4 to both sides. 104 equals 3x. We get x equals 104 over 3. In this type of equation, we are going to use the property that says if we have a base of a and it has an exponent that is a log with that same base of a of x, the result is just what we're taking the log of in the exponent, x. Because exponential functions and logarithmic functions are inverse functions, they undo each other and we are just left with the input of x. So the steps to solve these types of equations, we want to get log terms on either side of the equal sign. We want to make each side the exponent on the same base as the log, and then solve for x. So let's look at an example. In this example, we do want to change this plus to a minus. Okay, the first step then is to get those log terms on either side. So we're going to add that second log term to both sides. We end up with log of 3x plus 3 equals log of x minus 3. Okay, now is where we're going to use that second step. We are going to make either side of the equal sign an exponent, and we are going to choose the base to match up with what the log is. It is a common log, so we're going to choose the base of 10. So I am just going to say we have 10 to the log base 10 of 3x plus 3 equals 10 to the log base 10 of x minus 3. So based on that property, the exponent is just undoing that logarithm, and we are going to be left with just 3x plus 3 equals x minus 3. And so we get to step 3, which is to solve for x. So subtract x from both sides, we get 2x, and subtract 3 from both sides, we're going to get 2x equals negative 6. Solve for x, we get x equals negative 3. All right, there really is one more step we need to add to this list of steps for solving. And when we have an input to a log, we need to make sure that it is positive. So if we get an answer for x, we want to make sure that it is a solution by saying that what we put into the log, it has to be a positive. So we're taking log of 3x plus 3. So let's plug in that x value of negative 3 times negative 3 plus 3. So that gives us log of negative 9 plus 3, which is log of negative 6. Okay, because we're taking log of negative 6, that is undefined. All right, negative numbers are not in the domain of the log function. So since x equal to negative 3 gives us an input to the log that's negative, we say that it is not a solution. And so that means there's no solution to this equation. All right, let's try this example. We want to get those log terms on either side. So we're going to add that second one to both sides. So we get log of x plus 5 equals log of 4x squared plus 5. Okay, these are common logs. So in our second step, we are going to make each of these log terms the exponent on that base of 10. So the exponent undoes the logarithm, and we are just left with x plus 5 equal to 4x squared plus 5. And now we want to solve for x. So let's get all the terms on the same side. 4x squared, let's subtract x, and then if we subtract a 5, it's just going to be 0. So we end up with 4x squared minus x. So we have a quadratic. We can factor out a greatest common factor of x. So we bring out the x. We'll be left with 4x minus 1 equals 0. We set our factors equal to 0. We get x equals 0. 4x minus 1 equals 0, which is going to give us x equal to 1/4. Now we want to make sure that these aren't going to make one of our inputs to the log negative. 0, if we put 0 in, we would end up with log of 5 on both sides. And if we put a 1/4 in, that's going to make both of those things positive. So here we have two solutions, x equals 0, x equals 1/4.